Good afternoon. Welcome back for the chemical bonding class basics, and we are discussing the deviations in the octet rules. We already seen the lithium chloride, beryllium hydride, boron trichloride, nitric oxide, nitrous oxide. Now we will see some more the deviations in there. That is called the expanded outlet. Expanded outlet, in that there are some 3-4 colors. One is PF5, SF6, and sulfuric acid. We will say one or two first. Phosphorus. How much is the phosphorus? PF5 we will say. Phosphorus is 7 plus 8, that is nothing but 15. 7 is nitrogen, 15 is this same family. F5. Okay. This is only the atomic number for the convenience. So there are 5 bonds with P. So P1, that is 1 electron, 2 electrons, 1 electron, 2 F, 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 F. So if you see, octet rule for the fluorine is matching. This is fluorine is nothing but 9 plus 1, 10 in each case. So octet for the fluoride is matching. But whereas if you see phosphorus, what is the electron structure? 1s2, 2s2, 2p6, 3s2, 3p5. If you see these two are in the internal, we say the last 5 electrons are okay. But what is happening? 5 plus 5, 10. Octet, it is the outermost, it is 10, not 8. It is not 8, it is 10. So it is called expanded outlet, octet. Sorry. So it is above the more than the octet rule. So PF5. If some question is asked, expanded octet rule, the PF5 is one of them. Similarly, SF6 also. SF is you have to write 6, 1, 2, 3, 4, 5, 6. Here also same fluorine is matching. If you say 1 electron, 1 electron, 1 electron, 1 electron, 1 electron, 1 electron. Here the electron structure, if you see the sulfur, that is 1s2, 2s2, 2p6, this is inner, 3s2, 3p4, 6 electrons are matching, 1, 2, 3, 4, 5, 6. Fluorine also octet rule is matching, but whereas sulfur, it is in the outlet, here it is 12 electrons, not 8. It is not 8. So similarly sulfuric acid also. So these are the called expanded octet. OCTET, octet. Expanded octet is 3 examples: phosphorus pentafluoride, sulfur example fluorine, sulfuric acid. So sulfuric acid was similar, right? So these are the expanded, means it is beyond 8. Some are the lesser. Lithium chloride is lesser, beryllium hydride is lesser, boron trichloride is lesser, nitric oxide is different, nitrous oxide is different. These are the expanded. So all these things are one has to remember. Similarly, now in the ionic character, what is the minimum required for the ionic bond? Ionic bond normally forming in the 1s, means 1a group, and first group and second group, 1s and 1s2, 1s1 and 1s2. Here is the 18 group, 17 and 18. Not 17, 18, it is 16 and 17. Oxygen family and nitrogen family, both 16 and 17. And here in this, if this both are forming, this is normal. That means it should have a low ionization enthalpy. It should have a high electronegativity. This is the one of the conditions. This is a low ionization enthalpy. Here it is the high electronegativity. This is the means the electronegativity difference should be more, and it should be easily give the electron. So then it will be forming anything. And lattice enthalpy will be the higher. Most of the ionic compounds are the what you call crystals. they are hard, they possess high melting point and high boiling point, and they dissolve in the polar liquids. Their solubility in non-polar liquids is very low, like benzene and CCl4, which is carbon tetrachloride, or any other ether solvents and all. But whereas in the water, the ionic compounds dissolve more. They are in the fused states, and the ionic bonds, they doesn't exhibit the isomerisms and all, and their lattice enthalpy is very high. And now some more things we'll see. Some more things are normally the bond length, one other property. The second property is bond angle, The third property is bond enthalpy. By name itself is very easy to remember and all these things, but small these things. What is bond length? Bond length with which means this is between two nuclei of the any atom. The distance between the two nuclei is bond length. If it is a 50%, it is the bond radius. Bond radius is different. Bond length is full between the two nucleus. Distance between the two nucleus is the bond length. The half of the bond length is the radius. How to find out? It is by the X-ray diffraction and electron diffraction, bond length. And all the bond lengths, whether it is same, there is again exceptions. What is the exception? Normally it is a homonuclear, it is a 50%, or the bond the distance is okay. But whenever there is a high electronegativity difference, like ionic compounds formation, then the bond radius is not the same as the bond length by 2. So it will be the bond length is the RA, one of the radius, and RB, and one more radius, plus C into XA minus XB, and this is C is a constant, and where is XA and XB are the electronegativities. Then RA, RB is anyway, it is the normal, otherwise if it is this much only, that means the bond length will be the RA plus RB. 50% of this one, 50% of this, even if it is heteronuclear or homonuclear. Homonuclear will be the same, heteronuclear and all these things. But whereas if the electronegativity is very high, then you have to take C is a constant, and that values will be given from the book and all these things. That is a bond length. Right. Then the bond angle. Suppose if you see the hydrogen and all these things, we write normally H2O means O like this. This is not correct. This is for simplicity we are writing. It is not H2O. H2O is a bond angle is like, it is a 104 degrees. How it has come? So this is will be the experimentally determined, and there will be so many other hydrogen formation, hydrogen attraction, hydrogen bonding, and so many things will be there. But so the bond angle is the angle between the orbitals containing bonding electrons and the central atom. So that is the bond angle. Bond angle will be the, what is the bond enthalpy? Bond enthalpy is the energy required, or amount of the energy to break 1 mole of the bonds, to break the 1 mole of the particular bonds. Again here the exception, I am not dealing with the double bond, I am not dealing with the triple bond, or we are not dealing with the even the only single bond. This is directly this thing. Means suppose hydrogen means HH. Here it the energy of the bond enthalpy, that is nothing but 435 kilojoules per mole. That means this much energy is to be given to break the hydrogen molecule into hydrogen atoms. Suppose oxygen, it is hydrogen. Oxygen, if it is oxygen means it is a O double bond, O. It is a double bond. So here it will be the slightly more, because it is attraction is more. So it is not just hydrogen breaking and oxygen breaking will not be same also. It is around 498 kilojoule per mole and all. If it is a nitrogen is a triple bond, N triple bond N. So that will be the much more difficult for breaking the bond, nitrogen. That will be around 946 kilojoule per mole. So if it is a hetero, that means like a HCl and all, that will be the different again. And if it is a H2O type, that means O H O H. Remember, these two are not same. If you are this will be the different and this will be the different. Though both are OH bonds only, once it is first one is removed, second one will be easier. So there is a, so if any question is asked, remember all the time, it is not an average or it is not a single. The first bond, if you see, it is 502 energy you have to kilojoule per mole you have to give. Whereas in the case of second, it is almost some 80 kilojoules less. That means you take either this or this as the one. After one will be the 502. The second one, if you want to break OH, it will be easier because there will be some other bondings and some other attractions. But average, if you see, both you can take by 2, that is 464 or whatever it is, and all these things. This is about the bond enthalpy. Then one more we will call the bond order. Bond order. So bond order and resonance and all these things tomorrow we will see. Thank you very much.